Hello everyone, good morning all of you. So welcome to this session on the topic bleeder resistor, so which is a part and parcel of the subject analog electronics. So see here, observe here, so it is the bleeder resistor. So it is a electronic component. So it is the photograph of the bleeder resistor. So see here, in a circuit you can observe the bleeder resistors. So all these are the bleeder resistors. So let's move further. So today I had selected a very simple topic. In further sessions, so I will take complicated topics. So please do subscribe, like, share and comment. So most of the people just watching the videos without subscribing, so please make sure that you have to subscribe before watching the videos. Okay, if you are new to the channel, so please do subscribe and share. So up to now we have 14k plus views. So join me in a Telegram. So I had already posted the link in the chat box, so you can go through that. So let's move to our topic. So mostly from now onwards the sessions will be in the live format. So observe here, introduction. So bleeder resistor, it is a standard high value resistor. So here the question arises, so what is the difference between the normal resistor and the bleeder resistor? So what is the difference between the normal resistor and the bleeder resistor means? So bleeder resistor is also like a normal resistor, but it has a high value resistor. It is a high value resistor. Okay, its size is also somewhat bigger when compared to the normal resistor. So that's a small difference between the normal resistor and this bleeder resistor. So remember guys, bleeder resistor is an electronic component. So okay, so bleeder resistor is a electronic component, but it has a standard, it is a high value resistor. So it is a high value resistor, so its size is also somewhat bigger when compared to the normal resistor. Okay, so it is always connected in parallel with the capacitor. In a filter circuit, this resistor, this particular bleeder resistor is always connected in a parallel with the capacitor. So in further slides I will tell why we are connecting this bleeder resistor in parallel with the capacitor. Okay, so the main function of this bleeder resistor is it will provide the discharging of a capacitor. Okay, it will provide the discharging of the capacitor. It is the major application of the bleeder resistor. Okay, bleeder resistor is a electronic component, so it's a simple thing. So it will provide the discharging of a capacitor. So why we need to discharge the capacitor? We had already known the capacitor stores the electrical energy. The capacitor stores electrical energy. Okay, so the capacitor will not immediately discharge the electrical energy. It will not discharge immediately. So this bleeder resistor will helpful to discharge this electrical energy completely. So it is the major application of the bleeder resistor. So what is the use to discharge the electrical energy in a capacitor? Why we need to discharge the electrical energy in a capacitor? It means if the capacitor will not discharge properly, it leads to an electric shock to the person who is operating it. Okay, so it is a major drawback. If the capacitor will not discharge properly, it leads to an electrical shock. It leads to an electric shock to the person. So in order to avoid the electric shock, we have to connect this bleeder resistor in parallel with the capacitor. Okay, so it is the main thing. So in order to overcome the electric shocks in the circuit, we are using the bleeder resistors. That too, this bleeder resistor is always connected in parallel with the capacitor. Okay, so thus to ensure the safety of operations working with it, it is necessary to connect a resistor in parallel with the capacitor. So in order to ensure the safety in the circuit, we are using the bleeder resistors. Okay, in gadgets like TV, which requires high DC voltage for its operation, so this voltage is very high, the charge on the capacitor stays when the equipment is switched off. Simply we are using the in gadgets like TV and radios, we are using these bleeder resistors in order to provide the discharging of the capacitors. So if the capacitor will not discharge, it leads to electric shock. So it is mandatory to connect this bleeder resistor in order to provide the discharging of a capacitor. Okay, so let's move further. So next, significance of a bleeder resistor. So what is the importance of a bleeder resistor? So observe here, it is an experimental circuit I am considering. So it is one of the experimental circuit. So see here, the supply, the input to this experimental circuit, the particular this input to this particular experimental circuit is from the rectifier. Okay, here the output of the rectifier will be act as a input for this experimental circuit. Okay, so this particular the output of a rectifier will act as a input for this experimental circuit. So he can observe the filter circuit here. So all this part, it is a filter circuit. Up to this part, it is a filter circuit. The filter circuit will consist of the inductors and the capacitors. So observe here. So here it is a bleeder resistor. So observe here, this bleeder resistor will connect in parallel with this capacitor. It is a load resistor. So in this way, we have to connect the bleeder resistor in parallel with the circuit. Okay, it is a filter circuit. Filter circuit will consist of normally inductors as well as capacitors. So okay, so what if forgot to connect this bleeder resistor? So here I am considering the two cases. So it is a first case. I am considering the two cases. Here it is a first case. So what if you forgot to connect this bleeder resistor in a circuit, what will going to happen? Okay, it is the case one. Here I am switching on the power supply. Here the power supply is on, capacitor is there. So I am considering just a simple example, that's it. So here the power supply is on, the capacitor is there, but the bleeder resistor is not connected here in this particular circuit. So what will happen? So if you not connect the bleeder resistor when the power supply is on to the, if you not connect this bleeder resistor in parallel with this capacitor, so it will lead to an electric shock to the, so it will the operator will experience an electric shock. Okay, so that's why it is a major drawback. If you don't use the bleeder resistor, it leads to an electric shock. So it is the case one. In this case, the power supply is on, but the bleeder resistor is not there. So in this case, we can observe the electric shock. See, observe another case. Here in this particular case, I am here the power supply is off. Here the power supply is off. The capacitor is there, but here also the bleeder resistor is not there. Bleeder resistor is also not there. So here in this case also, it is the case 2. So in this case, so in this particular case also, the operator will experience an electric shock. It is strange. So why this happen? Even though when the power supply is off, the operator will experience an electric shock. Okay. So let me explain the reason. So what is the reason behind this electric shock? Even though if you switch off the power supply, what is the reason behind that? So when the power was switched on, so here I am considering the reason why this electric shock will occur even though when the power supply is going to off. So the reason is, so when the power supply is on, when the power supply is on for a particular circuit, so the capacitor will charges to its peak value. Okay, so the capacitor charges to its peak value. So after switching off the power supply, the capacitor is still in charging condition only. Okay, because it consists of the previous charge. So if you touch this capacitor, we will experience electric shock irrespective of the power supply. So see here, irrespective of the power supply, the user will experience an electric shock. Why? Because the capacitor will stores the energy it will store the electrical energy. Even the power supply is going to off, the capacitor will not discharge that electrical energy. Some form of energy will be stored in the capacitor. That's why the user or the operator will experience an electric shock even though when the power supply is on. So irrespective, so always remember guys, when the power supply is going to off or on, we have to connect the bleeder resistor in parallel with the capacitor. If you don't connect, it leads to an electric shock to the operator. So therefore we need a resistor so the capacitor can discharge properly after switching off the power supply. Irrespective of the power supply, whether it is on and off, we have to connect the bleeder resistor in parallel with the capacitor in order to overcome the electric shocks. So how to choose a bleeder resistor? How can you choose the bleeder resistor? What is the formula for a bleeder resistor? So it is the formula. So R equal to minus T by C into ln of V safe to V naught. So it is the formula in order to choose a bleeder resistor. Initially I had said bleeder resistor is a high value resistor. It is a standard high value resistor. So that high value can be calculated by using this formula. So it is the bleeder resistor formula, that is R equal to minus T by C into natural logarithm of V safe to V naught. Here T means time, R means resistance, C means capacitance. So V safe is the safe voltage up to which it can be discharged. So V naught is the initial voltage. So it is the just a formula. So in order to choose a better bleeder resistor. Okay. So next one, applications. So what are the major applications of this bleeder resistor? So initially I had said the main purpose of bleeder resistor is to ensure the safety in the circuit. So in order to ensure the safety in the circuit, we are using the bleeder resistor. So in order to overcome the electric shocks, we are using these bleeder resistors in a circuit. So main purpose is it provides the safety. So thus it is a crucial device for protection from electric shocks. Okay, it is the major applications. So another applications are also there. So another application of this bleeder resistor is it provides a better voltage regulation. So it will also used to divide the voltage. So these are the another two applications of a bleeder resistor. So the bleeder resistor will help to achieve the better voltage regulation. Okay, this voltage regulation is defined as the difference between no load voltage. So it is the voltage regulation means no load voltage minus full load voltage to full load voltage. So it is the voltage regulation formula. So in absence of a bleeder resistor, this numerator part, that is difference between no load voltage to full load voltage is very high. This regulation is not going to improve. Okay, simple thing guys. So if you don't connect the bleeder resistor, voltage regulation is not improved. If you connect the bleeder resistor in a circuit, voltage regulation will improve. Voltage regulation means it will regulate the voltage. So it will overcome from the fluctuations. Okay, it will always regulate the voltage. It will avoid the fluctuations in a voltage. That's it. Okay, if you connect the bleeder resistor, it will regulate the voltage. That's simple thing. So next application, it is a third major application of bleeder resistor is the voltage division. Okay, so if you want your circuit to provide more than one or two voltages, it can be achieved by using this particular bleeder resistor. So if the circuit will provide one or two voltages, if the circuit want to provide one or two voltages, by using bleeder resistor we can achieve this. So here we have used the tapping mechanism. Here we have to tap the bleeder resistor at three different points in order to get the three different voltages as outputs. Let me show the diagram. So this observe here. Here it is a bleeder resistor. So I had already said, so in capacitor we are connecting this bleeder resistor in parallel with this capacitor. Here this bleeder resistor is tapped at three different points in order to get the three different voltages. So see here it is a bleeder resistor. This bleeder resistor is tapped at this point and this point and this point in order to get three different voltages V1, V2 and V3. Voltage division. That means in order to divide the voltages, in order to get one or more than two voltages, we are using the bleeder resistor in a circuit, where if you tap the bleeder resistor, we can get the different voltages from a single circuit. So all these are the all the advantages of this bleeder resistor. So that's it, guys. So bleeder resistor means it is one of the simple electronic component. It will help us to avoid the electric shocks if you connect this bleeder resistor in a circuit. Okay, guys. Thank you all.